Now we are on the second video clip of solving right angle triangles. On the screen, we are going to treat two questions immediately. The first one states, if the diagonals of a rhombus are 16 centimeters and 12 centimeters respectively, calculate the length of a side of the rhombus. And number two states, a rectangle is 7 centimeters wide, and the length of each of its diagonal is 18 centimeters. Calculate the length of the rectangle. Let's start with number one. We'll look at the first one there. First and foremost, you need to know what a rhombus is. Without that, we can't solve this problem. What is a rhombus? A rhombus is a quadrilateral, just like your rectangle, your parallelogram, and co. But what's special about a rhombus? A rhombus has all sides equals and also looks like a kite. So you can see something like this. Yeah. It has all sides equal. This side will be equal to this, likewise this, and likewise this. As a matter of fact, a square is from the family of rhombus because a square has all the sides equal. Another thing again is the rhombus. The diagonals of the rhombus, if I take the diagonal that way and I take another diagonal this way, the diagonals bisect each other. By bisecting, we mean it divides each other into two equal halves. Not just that, for a rhombus, they bisect each other at 90 degrees, unlike that of what a rectangle or a parallelogram. The diagonals of a rhombus, likewise that of a square. Remember I said a square is from the family of the rhombus. The diagonals always bisect each other at 90 degrees. So we're going to use this information to sketch out our rhombus. We are told that the diagonals are 16 centimeters and 12 centimeters. So the longer one is 16. That is from this point down there is 16, while the shorter is 12. And since we know that the diagonals bisect each other, it means the longer will be 8, 8. And then the shorter will be 6, 6. You can see there we have about 4 right angle triangles. This is one, that is another. Here we are, and that's another one. All we have to do is just pick one of them. I can pick this right angle triangle here out, knowing that this side is 8 and this side is 6. I can use this right angle triangle to find the hypotenuse, which happens to be the what? The length of the side of what? Of the rhombus that we are looking for. So let's have this in a neater form. That's it. So you can see our rhombus well drawn out, and the length of the side has been given the symbol A. So we are actually looking for A. Bringing out one of those triangles, we have this. Remember that the diagonals bisect each other at 90 degrees, so that gives us a right angle triangle. And we can apply our Pythagoras theorem there. And of course, Pythagoras theorem says what? That a square, that is the hypotenuse square. That's my A, please don't take this for 9. That's a square is equal to the sum of the squares of the other two sides. So that's 6 square. And this gives us 64 plus what? 36, which is 100. So a square is 100. What is a? Square root of 100. And that gives me 10. Which means the length of each of the side of the rhombus is simply 10 centimeters. That's it there, written out in much more neater form. A square is equal to 8 square plus 6 square. Let's proceed to question number 2. Question number 2, we are told that the rectangle is 7 centimeters wide, and the length of each of its diagonal is what? 18. So we are given the width of the rectangle, but we are not given the length of the rectangle. So we are asked to find the length of the rectangle. Rather, we have been given the diagonal. We know what a rectangle is. It calls a quadrilateral. just that the length and the width are not equal. And then something special there is that the rectangle has all angles as what? 90 degrees. So we have been told that the width, which can be this side or this other side, so I call this the width 7 centimeters. If you like, you can also put there 7 centimeters. And the length of each of the diagonal, let's just take only one. Each of the diagonal, if I draw it from here to that end, that's the diagonal. We are told it is 18 centimeters. Sorry, memory is running out. 18 centimeters. We are then asked to do what? Find the length. Of course, I can just find this length. Looking at this triangle, one, and there, that's a right angle triangle. Then we can proceed, right? So you apply what? Pythagoras Theorem. Let's draw this out more neatly. So that's the diagram. I'm very sure you appreciate that. Applying Pythagoras, where's our hypotenuse? Of course, this is our right angle. So the hypotenuse obviously is 18. So we say, okay, 18 square is equal to what? The sum of the squares of the other two sides. That is 7 square and L square. 18 square is what? Is 324. So we have the left hand side as 324. And then we have our 49 plus L square. And transferring 49 to the left hand side, we have 324 minus 49, giving us L square. That's L square equals to 275. And taking the square root of that, we have that the length of the rectangle is 16.58 centimeters. That's it for question number 2. Let's proceed straight to the next problem. This problem is a little bit bearing-like, but we are not fully into bearing yet. We are told here that an aeroplane flies 15 kilometers north. After that, of course, it now goes 20 kilometers east and then 3 kilometers north. Of course, we'll just start from somewhere to sketch. Let's say we pick up a point down there so that we can go up north. Let's pick a point here. So this is my starting point. And we are going up north, 15 kilometers. So I can say, okay, I travel up north. Sorry, my hand is shaking. 15 kilometers up north. After getting to some point, I decide to go 20 kilometers to the east. Yes, I'll do that a little bit longer because it's 20 and this is 15. This is 15 and that's 20. And then on arriving this point, we are told again it goes 3 kilometers north again. So up north, just 3 kilometers. What is the distance from the starting point? This is my starting point, and that's my end point. We are asked to find that distance. There. That's just it. So let's draw this out neatly. That's the first one. Assuming that we are starting from down here as a starting point. You can call this our starting point. And then we travel up north 15 kilometers, which means we're going to go east next. That's it, 20 kilometers to the east, and then after that 3 kilometers up north. And we are asked, what is the distance between these 2 points, the distance from the starting point? You will agree with me that we could also have traveled this journey this way, which will give us a right angle triangle right away. Look at, you could have gone like this, there, and that gives us a right angle triangle. Or you would have also gone up there and then this way. Whichever one we pick, we'll have a right angle triangle, and then we'll be able to solve for this side, which happens to be the hypotenuse because it's facing the right angle either way. Either we are looking at it this way or looking at it the other way. So let's proceed. So that's it. I'm walking right and then I go up. So my triangle is out. Remember, we are looking for the what distance from the starting point where it is now and where it was before. What's the distance in between? You can call this the starting point. If you like, you call it A. You call that B. If you like, you call this C. Whatever. Which means we are actually looking for what? A, B. I know AC because this is 20, right? Therefore, this is going to be 20 also. And I know BC is going to be from this end down to A is 15. So BC will be 15 plus 3 kilometers. That gives us 18. That's it. So that's the 18 kilometers and 20 kilometers. So we have ABC as our right angle triangle. Let's indicate our right angle there. Indicates there, that's our right angle. So we have a right angle triangle ABC. Next, we apply the Pythagoras Theorem. Which of these sides will be our hypotenuse? Clearly, we can see AB is the hypotenuse because it's facing the right angle. So I state that AB square is equal to the sum of the squares of the other two sides. And both of them, one is AC and the other is BC. Okay. AC is 20 kilometers, so that's 20 square. And BC is 18, obtained from 15 plus 3, that's 18 square. So that's it. So to get our AB is now a case of rice and beans. I'm sure we can all follow up from there. That's the first expression. Hypotenuse square is equal to the sum of the squares of the other sides. We substitute our values. 20 square is 400, 18 square is 324, and that's that line. Adding that up, we have 724. And taking the square root of the right hand side, that gives us AB to be what? 26.9 kilometers. And that's it for this video clip. In the next video clip, we introduce how we can apply Pythagoras Theorem in solving problems that will include a chord in a circle. So see you in the next